All right, guys, so we're back. So the y-intercept is the initial amount in the pitcher at time equals 0, or, so what is it initially? A pitcher with a maximum capacity of 4 cups contains 1 cup of apple juice concentrate. Okay, so it has 1 cup initially, right? You're starting with 1 cup of apple juice. Plot the point that corresponds with the y-intercept, so you're starting at 1 cup. And then you're filling up the water, right? And you're filling it up at 0.25 cups per second. So the slope or rate of change is 0.25 cups per second, or 1 cup in how many seconds? So if you're doing 0.25 cups per 1 second, move your decimal over twice, move your decimal over twice. You'd have 25 out of 100, which is 1 out of 4, right? You can't have a decimal, so 1 out of 4. So your slope is really 1/4. 0.25 is 1/4, or 1 cup per 4 seconds. So the rise is 1, and the run is 4. So up 1 over 1, 2, 3, 4. Rise 1, run 1, 2, 3, 4. Rise 1, run 1, 2, 3, 4. So it really should only go to here, right? Because it has a maximum capacity of 4 cups, right? It can only go up to 4 cups. So the rise of a run will move the first point to the second point of the line by moving up how many? Up 1 and right 4. And you're going to plot that second point. So we know that we're only going to go to here, though. So I think it's going to go into the domain and the range on the next page. Yeah. The graph is going by 4? Oh, so it's actually going by 2s. 2, 4, 6, 8, 10, 12, 14, 16. So this is, but it's only going by 1s here, which is why I didn't catch that. Sorry about that. I did mess up. Thank you so much for catching that. You have to be very careful about their scales because they did go by 2s down here and 1s over here, so I should have paid closer attention. So let's regraph this. So we had 1. We're going up 1 over 4, up 1 over 2, 4, up 1 over 2, 4, up 1 over 2, 4. There we go. So now that's actually what we needed to do. Okay, so then it says, connect the points and extend the line to a maximum value function where A of t equals 4 cups. The maximum value is 4 cups, right? So your domain, your t's, your x's. So your domain is your x, which is your t's in this instance, and your range is your y, or your A of t. So your domain, your x values, go from 0 to 12. And your range, or your y values, go from 1 to 4. Oh, you guys don't see what I'm looking at, sorry. So from 0 to 12 is your x's. From 1 to 4 is your y's. How could you use the slope and y-intercept to graph the function f of x equals 3? This is y equals 3. Well, how would you use slope and y-intercept to graph the function y equals 3? Well, think about y equals 3. This is your y, this is your x. Y is 3 everywhere along this line. Your slope is horizontal, so your slope is 0. You have 0 slope. Your y-intercept is 3. Well, let's think about this. Y equals mx plus b. This is 0x. That's why it's gone. So your slope is 0. Your y-intercept is that 3. So you have a y-intercept of 3 and a 0 slope, so it's horizontal. You have a y-intercept of 3 and 0 slope, so it's horizontal. What are the units of the rise in part B? What are the units of the run? Part B. What are the units of the rise? So you're rising, that's your change in y. That would be in cups. And then the run is going to be in seconds. Your rise is cups. Your run is seconds. How long does it take to fill the pitcher? Explain. So to fill it to the maximum of 4 cups, it takes 12 seconds. Why is the function rule a of t equals 1/4 t plus 1? Use units to justify your answer. Your slope, or rate of change, is 1 cup per 4 seconds. And you start with 1 cup of apple juice already in the cup, right? So this is your starting point. You started with 1 cup already there, your y-intercept, and you're increasing 1 cup per 4 seconds. Write the linear function f using the given information. The graph of the function has a slope of 3 and a y-intercept of -1. The linear function has the form y equals mx plus b, where m is the slope and b is the y-intercept. So your slope is 3, and your y-intercept is -1. So you're going to have f of x equals 3x minus 1, right? A different function has the value shown in the table. First, calculate the slope of 2 ordered pairs. Okay, so let's take, they're using these 2 points. So change in y over change in x. y2 minus y1, right? This is your xy, point 2, point 1. y2 minus y1 over x2 minus x1. Bam, 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 bam. -8 over 4 is -2. So your slope is -2. Find the value of b using the fact that your slope is -2 and f of -1 equals 5. This is your x, this is your y, right? If f of x equals y equals 5, and this is x. So you have the point -1, 5, xy, and you have a slope, which is your m, of -2. So y equals m x plus b, right? This is your y, this is your m, this is your x. You're just plugging in. Y equals mx plus b. -2 times -1 is 2. Subtract 2 from both sides, 3 equals b. Right? -2 times -1 is 2. Subtract 2 from both sides, -3 is b. So now that you have your b, y equals mx plus b. This is your m, this is your b. Make sense? You guys see how to write the equation? Using a point and a slope. In part B, use the ordered pair to check your answer. Let's see if it works. This is your x, this is your y. Y equals m x plus b. Right, I'm plugging into here. -14 plus 3. -11 equals -11. It sure does, so we know that we did it right. The point works. Write a linear function from a graph. The graph shows the increase in pressure measured in pounds per square inch. As a scuba diver descends, they go down, from a depth of 10 feet to a depth of 30 feet. Pressure is the result of the weight of the column of water above the diver as well as the weight of the column of the Earth's atmosphere above the water. Pressure is a linear function of depth. What is the pressure on the diver at the water's surface? All right, so when he's at a depth of, so let's look. We need to look at what our slope is here, right? So we're going down. We're going from a height of 28 to a height of 19.1. So we're going down what over what? So our slope, y2 minus y1 over x2 minus x1. So 28 minus 19.1. Grab a calculator. 28 minus 19.1 is 8.9 over 20. So it's really 0.445, right? If we wanted to put this into a fraction, we move our decimal over once, move our decimal over once, we would have 89 over 200, and we can reduce that, let's say. It doesn't reduce, so it's just 89 over 200. So you're going up 89 over 200, up 89 over 200. So that is your slope, right? So your slope is 89 over 200, or 0.445. All right, so what do they want us to do? They want us to interpret the question. Let D represent the depth and P the pressure at the water surface. D equals blank. For this value of D, so your depth is, what are they doing? Represent the depth. Oh, if you're at the surface, what depth are you at? If you're at the surface is 0, right? D equals 0. So for what does this mean in P of T in terms of the line and line segment? It's going to be when the depth is 0, you're going to have, what is your pressure? We want to know the pressure at 0. So we need to see, where does this cross? So it's going to be somewhere around here, right? So for what does this mean in terms of the line? Contains this line segment shown on the graph. So for here, it's the line's P-intercept, right? Because the Y-intercept or the P-intercept. So instead of saying Y-intercept, we're saying P-intercept because they're saying Y is P. Find the value of M in P of D equals MD plus B. Use the fact that P of 10 equals, so this is your X, this is your Y. So they're saying that at 19.1, 10 comma 19.1 is a point on the line, right? 10 comma 19.1, which is right here, right? And then they're giving you 30 comma 28 because this is your X, this is your Y. So these 2 points. And I took these 2 points and I did the slope formula right here. So I did 28 minus 19.1 over 30 minus 10. And I got 8.9 over 20. They are saying to write it in decimal form, 0.445. Okay? They want you to leave it as a decimal. That's nice of them. So 0.445 D plus B. Substitute 10 in for D and 19.1 for D. So 19.1 equals 0.445 times 10 plus B. So that's going to be 4.45 plus B equals 19.1. Subtract 4.45, so 19.1 minus 4.45. 14.65 is approximately B. Right? And it says round to the nearest tenth. So to the nearest tenth, 14.7. Okay? So B is approximately 14.7. pounds per inch squared. All right, so interpret the value of M in the context of the problem. So M is the rate of change in pressure with respect to depth. Write the function P of D equals MD plus B using the calculated values of M and B. Use the function to find the pressure of the diver at a depth of 20 feet. So we have P of D equals our slope. We got a slope of 0.445 D plus 14.7. That is our equation. Then they want us to do it with a depth of 20 feet. So we need to actually plug in a 20. 445 times 20 plus 14.7. 0.445 times 20 equals plus 14.7, 23.6. 23.6. And that's in pounds per inch squared. Here's this. This is our equation, and then this is our P of 20. Gives us this. You guys following this so far? All right, so writing and solving a system of equations. Mr. Jackson takes a commuter bus from his suburban home to his job in the city. He normally gets on the bus in the town where he lives, but today he is running a little late. He gets to the bus stop 2 minutes after the bus has left. He wants to catch up with the bus by the time it gets to the next stop in a neighboring town 5 miles away. The speed limit on the road connecting the two roads is 40 miles per hour, but Mr. Jackson knows that the bus travels the road at 30 miles per hour. He decides to drive at 40 miles per hour to the next stop. Does he successfully catch the bus there? Identify the independent and dependent variables, how they are measured, and how they will represent them. The independent variable is what? Your time, right? Time measured in minutes. Let T represent the time since Mr. Jackson began driving to the next bus stop. The dependent variable is the distance measured in miles. The distance depends on how long you've been driving, right? Let D represent the distance traveled. Since you need to track the distances traveled by both Mr. Jackson and the bus, the subscripts D of 1 will represent the distance traveled by Mr. Jackson, and D of B will represent the distance traveled by the bus. Write a distance traveled function for Mr. Jackson and for the bus. Each function has the form D of T equals RT plus D of 0, where R is the rate of travel and D of 0 is the initial distance. Although you know the rates of travel, they are given in miles per hour, which is incompatible with the units of time in minutes. So we're going to have to convert. You need to convert miles per hour to miles per minute. In the conversion table, express the miles as simplified fractions. So 40 miles per 1 hour, we want to get out of hours and into minutes. To get out of something, they have to be diagonal so that they cancel out. 1 hour is 60 minutes. So now we will be in miles per minute. So 40 miles per 60 minutes, or 4 miles per 6 minutes, right? 4 miles per 6 minutes, which is really 2 miles, 2/3, which is hold on. 40 divided by 60, that's 2/3, which is 0.6 repeating. So 0.6 repeating miles per minute, right? 0.6 repeating miles per minute. Which is really like 2/3, right? 2/3 miles per minute. All right, so then 30 over 60 is really 1/2 miles per minute. You guys agree? At the moment, Mr. Jackson begins driving to the next bus stop. The bus has traveled for 2 minutes. If you use Mr. Jackson's position as the starting point, the initial distance for Mr. Jackson is 0 miles. And the initial distance for the bus is, is 1/2 times 2, which is 1 mile. Because it's been 2 minutes, right? 1 mile. So the distance traveled functions are, Mr. Jackson is going to be 2/3 times t plus a starting point of 0. And the bus is 1/2 times t plus a starting of 1 mile, because it's already traveled a mile before Mr. Jackson gets going to start catching up. Determine the value of t for which d sub j of t equals d sub b of t. So we want to know, where do they intersect? Where do they meet? So we have to graph the two functions to see where they overlap. All right, so he's starting at 0, and he's going up 2 over 1, 2, 3. Up 2 over 1, 2, 3. Up 2 over 1, 2, 3. All right, so this is our DJT, Mr. Jackson. All right, so now let's look at the bus. The bus started at 1, and it's going up 1 over 2. 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 So where it actually intersects is right here. This is your bus. It intersects at 6 minutes, 4 miles. The t-coordinate of the intersection, so this is always your y and this is always your x, and it's always x comma y. So here we're doing t comma d of t, right? So the t-coordinate is going to be 6, and so Mr. Jackson catches up with the bus in 6 minutes. Check the result against the conditions of the problem and then answer the question. The problem states that the bus's next bus stop is how many miles away? 5 miles away. And the graph shows that Mr. Jackson catches up with the bus in how many miles? 4 miles. So does he successfully catch the bus? Yes. Explain how you can use algebra rather than a graph to find the time when Mr. Jackson catches up with the bus. Then show that you get the same result. All right, so let's write their equation. So his equation is y equals 2/3 t plus 0. And the bus is y equals 1/2 t plus 1. So if we set them equal to each other to solve, I'm going to subtract 1/2 t from both sides. So 2/3 minus 1/2, we can turn these into sixes, so that's times 4/6, and 1/2 would be 6/3, right? So 4/6 minus 6/3 is going to be -2. Wait, I can't make that a third. That needs to be a 6, so that's times 3. Sorry. 3/6. 4/6 minus 3/6 is 1/6, right? So -1/6 t, or positive 1/6 t, right? 4/6 minus 3/6 is 1/6. 1/6 t equals 1. So let's write that over here. 1/6 t equals 1. So multiply by 6 over 1 to both sides. T equals 6. So if I just take my two equations, and I'm going to substitute this in for the y here, right? Set them equal to each other and solve, then you get that it's 6. Does that make sense? You have the two equations, set them equal to each other, and then see what you get. And it does work. So, in terms of the context of the problem, explain why the y-coordinate of the intersection point and not some other point determines how long it takes Mr. Jackson to catch up with the bus. The two graphs are distance traveled graphs, and their intersection point is the only point on the two graphs where the distances are equal. The t-coordinate of this point gives the time at which this occurs. All right, so I want to do a few practice problems with you guys. Your homework is going to be, just so that you guys know, your homework is going to be page 223 and page 224 in your workbook. But I want to do some practice problems with you guys first. So let's do some of these. So maybe we can let's do the odds on this page. So on 1, y equals 3x minus 4. So we have a y-intercept of -4. We have a slope of 3. So -4 is our y-intercept. We rise 1, 2, 3, run 1. Up 1, 2, 3, over 1. Up 1, 2, 3, over 1. And here is the equation of our line. That is our graph line. This one says y equals -1. Well, y is -1 here, and it's everywhere along this horizontal line. Your y value, every single point on this line, the y value is -1. Your slope is 0. It's rising nothing, running something, and your y-intercept is -1. Here we have a y-intercept of what? What's my y-intercept? What? My y-intercept. Y equals m, this is your m, x plus b. Your y-intercept is -3. Your slope is 1/4. So you go to -3, you rise 1, run 1, 2, 3, 4. Up or down 1, -1, 2, 3, 4. That making sense, guys? I want you to try number, well, is there more of these? Try number 2 with your table partner. Try number 2. Right, so your y-intercept is 2. Put a dot at 2. And then you're going up 1 over 2, up 1 over 2, up 1 over 2, or down 1, -2, down 1, -2, down 1, -2, because a negative over negative is positive, right? So you can go either way. And our next one, what is my y-intercept? Plus b. It's my y-intercept is going to be 0, right? And my slope is 4/3. So y-intercept is 0, up 1, 2, 3, 4, over 1, 2, 3. Or down 1, 2, 3, 4, over 1, 2, 3. Try number 6. I go to 1 for my y-intercept, and I'm going down 5 in the positive direction 1, or up 5 in the negative direction 1. Graph the linear function, answer the question, explain your answer. A plumber charges $50 for a service call and $75 per hour. The total cost in dollars of the function is C of t, of time and hours on the job. For how many hours will the cost be $200, and how many hours will it be $300? All right, so it's $50 charge. So our cost, our C of t, is going to be $75 per hour plus the $50 for coming out. So no matter what, he's charging me $50 no matter what. Okay, so just to come out, he's charging me $50. So this is our hours, and this is our cost in dollars. All right, so if I have him for 1 hour, it's going to be my $50 plus $75 more, right? So 75 times 1 is 75 plus 50 is how much? 75 and 50? 125? If I have him for 2 hours, 75 times 2 is 150. 150 plus 50 is $200 for 2 hours. If I have him for 3 hours, 3 times 75 plus 50. So 3 times 75 plus 50. He's going to cost me $275. For 4 hours, add another $75. You're at $350. All right, so this is our graph in terms of his cost. All right, so when is the cost going to be $200? Well, 200 is going to be at 2 hours. $200 for 2 hours. When's the cost going to be $300? $300 for, well, we actually have to solve that one. 300 equals 75t plus 50. So subtract 50. 250 equals 75t divided by 75. So 250 divided by $75 an hour in 3.3 repeating hours. So for 3 1/3 hours. What is a third of an hour? If an hour is 60 minutes, 60 divided by 3 is 20. So for an hour and 20 minutes, right? For an hour and 20 minutes, he's going to charge me $300 because 3 1/3 hours. And a third of an hour, a third of 60 minutes is 20 minutes. Write the linear function with the given information. The graph of a function has a slope of 4 and a y-intercept of 1. Y equals 4x plus 1, right? Slope of 4, y-intercept of 1. The graph of a function has a slope of negative 2/3 and a y-intercept of 5. Y equals negative 2/3 x plus 5. That's how you write the equation. All right, how about this equation? Well, my y-intercept is when x equals 0, so I know I have a y-intercept of 5, and we need to know what our slope is. We'll take 2 of these points and figure it out, right? Change in y over change in x. These are your y's. So right here, we're going plus 3 minus 3, right? Or you can actually write the points if that makes it easier for you. 0, 5, and 3, 2. Change in y. y2 minus y1 over x2 minus x1. Negative 3 over 3 is a slope of negative 1. So you know you have a slope of negative 1. Y equals negative 1x, or negative x, plus 5. Are you guys following me with this? Is this making sense? Okay, so next one. We know we don't have our y-intercept. Let's find out our slope, right? So if we had 1, negative 1, and 2, 5. 5 minus negative 1 over 2 minus 1, bam, bam, 6 over 1. So my slope is 6. Y, and then let's use a point and plug in. Here's an x, here's a y. y equals mx plus b. 6 plus b equals negative 1. Minus 6. Negative 7 equals b. So now I have my b and my m. Y equals mx plus b. See how I did that? So I used 2 points to find my slope, y2 minus y1 over x2 minus x1. And then I used a point for an x and a y, plugged it into y equals mx plus b to find my b. Once I have my b, write it with my slope and my b. Write the linear function using the given information. All right, so we have a y-intercept of negative 1. What's our slope? Up 1, 2 over 1, up 1, 2 over 1, up 1, 2 over 1, a slope of 2. Y equals 2x minus 1. See how I did that? And I think this is a good stopping point. So this was your lesson on 4.6, graphing linear functions. I hope you guys enjoyed this lesson. Good luck on your homework tonight, which is on pages 223 and 224. Like and subscribe, and have a fabulous day.